In this video, we will do an example where we maximize a multivariable profit function. So here's the example. A cruise line sells two kinds of tickets to passengers, luxury and economy class. Economy passengers pay $2,000 for the cruise, while luxury passengers pay $3,500. The cost, in hundreds of dollars, of taking X economy passengers and Y luxury passengers is given by this formula, C of X comma Y. Part A asks, find the combination of passengers that will maximize the profit. Okay, so this question is asking me to maximize the profit. So I'm probably going to need to write down what the profit is. So we call that profit, if I call it capital P, is revenue minus the cost. And then I'm going to need to say, well, what is my revenue? Because I have the cost function already. So for revenue, we're getting revenue from economy passengers, and we're getting revenue from luxury passengers based off of how many of each there are. So in general, remember that revenue is price times quantity. But in this case, there's two types of price. There's the price for economy tickets and there's the price for luxury tickets. So what I'll have to do is I'll have to take into account the price of economy. I'm just going to abbreviate EC, economy tickets, times the quantity of, maybe let me say econ tickets, economy tickets, and then plus do the same thing with luxury tickets. So the price of luxury, let me just say ticks, price of luxury tickets times the quantity of luxury ticks, again for tickets. And now let's plug in the values that we have for these. So we'll get R equals, what's the price of an economy ticket? It's $2,000. But in our problem, it says that we're considering the units of cost to be in hundreds of dollars. So what's 2,000 in hundreds? Well, it's 20. It's 2000. So we'll get 20 times the quantity of economy tickets is saying is X. There's X economy passengers. Plus, doing the same thing for the price of a luxury ticket, 35,000 in terms of hundreds would be 3,500. So we'd have 35. And then the quantity of luxury tickets is Y, because the problem says there's Y luxury passengers. And that is our revenue function right there. And this units wise again is in hundreds. All right, so we're ready to do revenue minus cost now to write our profit. Okay, so our profit is going to be equal to that revenue, which was 20x plus 35y minus the cost function, which I have to put in a big parentheses. So it was 1 over 40 x squared plus 1 over 15 xy plus 1 over 10 y squared plus 800. So next we could take this negative sign and we could distribute it. So that gives us profit equals, we'll get 20x plus 35y in front, and then minus 1 over 40 x squared minus 1/15 xy minus 1/10 y squared minus 800. So we have our profit function. It's a multivariable function. It involves x and y. So we are now ready to find our critical points. So I'm just going to call them critical points. So we take the partial derivatives and set them equal to 0. So let's find the partial with respect to x, the partial with respect to y, set them both equal to 0. Okay, first for the partial with respect to x. For the first term, that derivative is going to be 20. The next term's derivative is going to be 0 because there's no x's in it, and y gets treated as a constant. Okay, for the next term, the 2 would come down, and I'll get minus 1 over 20x. Okay, for the minus 1 over 15xy, the partial with respect to x is going to be minus 1/15th y. And then for the last two terms, there's no x's in them, so they get treated as constants. So their derivatives are going to be 0. So that equals 0. So if it was a little unclear how I got that derivative, I definitely encourage you to pause the video and go through it slowly at your own pace. Feel free also to go back to our video on partial derivatives from section 8.2 to review that. Okay, so now let's do the partial with respect to y. So first term, 20x, that's going to be 0 when I do the derivative, because there's no y's in it. For the 35y, that derivative is going to be 35. For the next term, I'll get 0. For the minus 1/15th xy, that I'll get minus 1 over 15x. And then for this next term, I'll get minus 1/5 y squared. And then for the minus 800, that's a constant, so that derivative is going to be 0. So we have this equals 0. So we have these two equations. I'll call the first one equation 1, and the second one equation 2. So overall, we have a system of equations. And we've seen systems of equations when we did our previous examples in this section of finding local maxes and local mins. So we can do stuff like isolate a variable in one equation and plug it into the other one. And whoops, I realized I made one mistake here. I wrote minus 1 over 5y squared, but that squared shouldn't have been there. So I'm erasing that squared. It should just be minus 1 over 5y. Okay, so what I was saying was we could do stuff like substitute once I isolate a variable in one equation into the other. Or I could do stuff like maybe try to add the equations or multiply an equation by something and then subtract it from the other. In fact, that is what I'm going to try to do. I'm going to try to take my first equation, equation 1, and what I'm going to try to do is I'm going to try to make this minus 1 over 15y term become minus 1 over 5y, so it matches up with the term below it in the next equation. Because then I'll be able to subtract the equations and get them to cancel. So I would need to multiply the first equation by a 3. And if I do that, if I multiply both sides by 3, we'll get 60 minus 3 over 20x. And then 3 times minus 1 over 15 is going to be minus 1 over 5y. And then 3 times 0 is 0. Second equation, I won't multiply by anything. And I'll leave it as 35 minus 1 over 15x minus 1 over 5y equals 0. Because now what's nice is we can subtract our two equations. So if I do the top equation minus the bottom one, the minus 1 over 5y's will cancel with each other, and we will be left with, let's see, 60 minus 35 is 25. I have this minus 3 over 20x from the top equation, and then minus negative 1 over 15x. So double negative becomes a plus 1 over 15x. And then equals 0 minus 0 is 0. So now let's just simplify this a little bit. For minus 3 over 20x and then plus 1 over 15x, we would need to get a common denominator. So this first fraction, I'm going to multiply the top and the bottom by 3, and that'll give me minus 9 over 60x. And for the 1 over 15x, I'll multiply the top and the bottom by 4 to get plus 4 over 15x. And let's move the 25 over to the right, so minus 25. Dang, I keep making some arithmetic mistakes here. So on the denominator, sorry, that should have been 4 over 60 instead of 15. Okay, so now combining these, we get negative 5 over 60x equals negative 25. And negative 5 over 60 simplifies to negative 1 over 12. X equals negative 25. And now I can isolate the x if I multiply both sides by negative 12. So we get negative 25 times negative 12. And then multiplying those, we get 300. So we have our value of x. So now to get y, we can plug this value of x into either equation here. To get y. One quick thing that I want to notice about these equations that I had was, both of these equations are linear equations. So with linear equations, doing what we did, this process is something called elimination, where you multiply one equation by something so you could add it or subtract it to the other one to get some cancellation. That's really nice with linear equations. Okay, and with linear equations, when you have one of your values for your variable, you can plug into either one and it should work just fine. Okay, so we plug into either equation to get y. So let's plug into, let's see, the second one, which was 35 minus 1 over 15 times x, so 300, and then minus 1 over 5y equals 0. So if I simplify this, 300 gets divided by 15 evenly, so I'd get 1 left over on the bottom, and a 20 up here. 35 minus 20, that is 15. And let's move the negative 1/5 y to the right. So I get positive 1/5 y. And then let's multiply both sides by 5. So we get y equals 15 times 5, which is 75. If we had plugged 300 into the other equation, we would have gotten the same thing. We would have gotten that y is 75. So we have our critical points. The x value is 300, and the y value is 75. So we are ready now to find h, our Hessian. So we want to find h now. So recall what our partial derivatives were. The partial of our function with respect to x was 20 minus 1 over 20x minus 1 over 15y. And the partial with respect to y was 35 minus 1/15 x minus 1/5 y. So recall the formula for h is pxx times pyy minus pxy squared. So our function is called p here for profit rather than f. That's why I'm writing pxx times pyy instead of fxx times fyy. All right, so now let's compute these partials. So for pxx, I got to look at px, this partial with respect to x, and I got to do the partial one more time with respect to x. And that'll give me negative 1 over 20. For pyy, I got to look at py and do the partial one more time with respect to y, and that will give me negative 1/5. And then for pxy, let's see, if I do it in this order, I would look at px and then do the partial of that with respect to y, which will give me negative 1/15. By Clause's theorem, the order shouldn't matter. So if I had looked at py instead, and then done the partial of that with respect to x, I would have also gotten negative 1/15. So that's kind of nice. All right, so simplifying this, we get 1 over 100 minus 1 over 225. And what we care about is that this is greater than 0. It is positive. So we are ready to test our critical point now. So I'm going to make our table where I keep track of the critical point, h, pxx, and the conclusion. So our critical point was 300 for x, 75 for y, and the value of h was positive. And when it's positive, I do need to know what pxx is. Pxx was a negative 1 over 20. Okay, so when h is positive, but pxx is negative, the conclusion is that we have a max. Okay, and I didn't mention this before, but this question asked us to simply maximize the profit. Notice it didn't specify whether it wanted a local max or an absolute max. And like we mentioned in the previous video, when a question doesn't specify which one, if it just says the max or the min, it means the absolute one. And we mentioned in the previous video that to find the absolute max or the absolute min, we're just going to assume that our local max or the local min that we got from the second derivative test is the absolute max or absolute min. So I just need to answer the question, which was, what did it want? The combination of passengers. So it wanted how many economy passengers and how many luxury passengers give us this max. Okay, so those are the values of x and y. We need 300 for x. So that's economy passengers. 300 economy passengers. And 75 was y. That's luxury passengers. 75 luxury passengers to maximize the profit. And that's our answer to part A. It wanted the values of x and y. How many passengers of each type would give us that max. So now part B asks us to find the maximum profit. So let's remember what our profit function was. It was 20x plus 35y minus 1/40th x squared minus 1/15th xy minus 1/10 y squared minus 800. So now I know what value of x and y give us the max. So we just need to plug those in to find what that max profit is. All right, so we got to take our profit function and plug in 300 for x, 75 for y. So doing that, we'll get 20 times 300 plus 35 times 75 minus 1/40 times 300 squared minus 1/15th times 300 for x times 75 for y. Almost there. Minus 1/10. 75 squared for y. Plugging in 75 for the y and then squaring it. Minus 800. And with this, if I evaluate this with a calculator, we end up getting 7,025 over 2, which as a decimal is 3,512.5. And what were the units? The units of our functions here were hundreds of dollars. So it might be just easier to read this if I were to convert it to dollars. So if I have something in $100 and I want to convert it to dollars, I need to multiply this by 100. And that's going to move the decimal place over to the right 2 spaces. So I'll get 3, 5, 1, 2. Move it over once. Move it over twice. So I need a 0. And that many dollars, so I can read it better. Let's put a comma there. 351, comma 250. It's about $350,000. That's their profit, maximum profit. Alrighty, so in the next video, we'll do another profit maximization question, but where there are 2 demand equations given.